So welcome to the video. Today we're going to take a look at how to do an independent t-test on version 31 of SPSS. So we're normally going to use this test when we have an independent categorical variable comprised of two levels and when we have a continuous dependent variable. So for this example, we are going to imagine that we are interested in the perceived effectiveness ratings that people have given to two different types of adverts. So these perceived effectiveness ratings are in this column here, and we have two different types of adverts. So we have the number 1 representing a type of advert in which a celebrity appears, and we have the number 2 in this column representing a type of advert in which a celebrity does not appear. So we're going to use the independent t-test to see whether there's a difference in the perceived effectiveness of these two different types of adverts. So the first thing we're going to do is go over to SPSS and then we'll go to variable view and we're going to give a name to our independent variable. So we'll call this something like adverts underscore type, and I'm using an underscore between the two words because I can't use a space here. And then we'll give a name to our dependent variable, so this will be something like perceived effectiveness. Then we'll go to this values column and we'll click on the advert type row and then on this box here, and then we'll click this plus button and we'll say that a 1 equals celebrity, so that refers to an advert in which a celebrity appears. We'll click the plus button again, we'll enter a 2 and we'll type no celebrity here. Then we'll go to OK, and then we'll use the measures column to indicate that advert type is a nominal or categorical variable, and we'll use the measures column as well to indicate that perceived effectiveness is a scale variable, which is otherwise known as a continuous variable. Next, we'll go down to data view and we'll see that the names of these two variables have appeared at the top of these two columns here. So then we're ready to copy and paste the data from this Excel spreadsheet into SPSS. So I'm going to select this top left piece of data, then I'll scroll down, and then while holding shift, I'll select this bottom right piece of data. I'll then go to Command or Control C to copy those data. Then I'll go back to SPSS and I'll select the top left cell and I'll go to Command or Control V to paste those data in. So this analysis has a couple of different assumptions. One is that the data are normally distributed within each of the groups, and the other is that we have something called homogeneity or variance. And as I've said in this note here, if you find that these assumptions are not met, you might consider doing a Mann-Whitney U-test instead, which is the non-parametric equivalent of the independent t-test. So we can check this homogeneity or variance assumption as we run the test, but we need to check this normality assumption before running the test. So to do this, we can go up to Analyze and then down to Descriptive Statistics, then across to Explore. And then we can transfer our independent variable to the factor list box and our dependent variable to the dependent list box. Then we can click Plots and then we can tick Histogram. We can deselect Stem and Leaf and we can tick Normality Plots with Tests. Then we can go to Continue and then to OK. And we can see if we scroll down slightly that we have this tests of normality table and we have two tests within this table. So we have the Kolmogorov-Smirnov test on the left and the Shapiro-Wilk test on the right. And we can see that we have 30 people in each of our conditions. And typically when we have fewer than 50 in each condition, we use the Shapiro-Wilk test. And typically we use this Kolmogorov-Smirnov test when we have more than 50 in each condition. So since we have fewer than 50, we're going to focus on this side of the table. And what we want to see is that we have sig values above 0.05 in both of these rows. So here we can see we have a value of 0.283 and here we have a value of 0.058. And as both of these values are above 0.05, it suggests that the data for the celebrity and no celebrity conditions are both normally distributed. So we'll say that the data are normally distributed, and then we'll go up to Analyze, and then we'll go down to Compare Means and Proportions. Then we'll go over to Independent Samples t-test, and we'll transfer our independent variable to the grouping variable box, and we'll transfer our dependent variable to the test variable box. Next, we'll tick Homogeneity or Variance test. Then we'll click on our independent variable and then on Define Groups. And as the default, SPSS uses 1 and 2 here, and those actually are the numbers that we allocated to our two conditions. So nothing needs to be changed here. So we can just go to Continue and then to OK to run the analysis. So the first thing I'm going to look at is this homogeneity of variance test table where we have Levine's test. And what we want to see is that the value in the sig column is above 0.05. So here we can see we have a value of 0.057. So that's just above 0.05. 0.05. So that suggests that this homogeneity or variance assumption has been met, which basically means that the data are spread out to a similar extent in both conditions. And what you see here actually determines which of the rows in this table above you look at. So if you have a value above 0.05, you should look at this equal variances assumed row, and if you have a value below 0.05, you should look at this equal variances not assumed row. So as my value is just above 0.05, I'm going to focus on this row here. And then if we look at this significance part of the table, we can see that we actually have two columns within it. So we have a one-sided P column and we have a two-sided P column. And which of these you look at is actually determined by what type of hypothesis you have. So a one-sided hypothesis is something like it was hypothesized that perceived effectiveness scores would be significantly higher in the celebrity condition compared to the no celebrity condition. And a two-sided or non-directional hypothesis would be something like it was hypothesized that there would be a difference between those two conditions. So the two-sided hypothesis is less specific than the one-sided hypothesis. So let's imagine that we had a one-sided hypothesis. So we're going to look at this one-sided P column within the significance part of the table. And we can see that we have a sig value of less than 0.001. So as this is less than 0.05, it indicates that there was a significant difference in the perceived effectiveness between the two groups. And if we look at this group statistics table, we can see that we have a mean of about 79 for the celebrity condition and a mean of about 69 for the no celebrity condition. So the perceived effectiveness scores were significantly higher in the celebrity condition compared to the no celebrity condition. So that's essentially how we interpret the results of the independent t-test, but let's take a look now at how we can report those results. So I have an example here, and I've said firstly why we did the test. So I've said an independent samples t-test was conducted to compare effectiveness ratings in the celebrity and no celebrity conditions. And then I've said that Shapiro-Wilk tests indicated that the data were normally distributed in the celebrity condition and in the no celebrity condition. And then I've inserted these stats from the normality test that we did. So let's just take a quick look at where those come from. So if we scroll back up, and we can find this Shapiro-Wilk test, and we can see here that we have a statistic. So this is the W value of 0.96. So that's what we have here. We have this degrees of freedom value of 30, and we have this P value of 0.283. And so here is the degrees of freedom value, and here is the sig value, also known as the P value, of 0.283. And then we just have the same statistics again for the no celebrity condition. So those are what I've reported here. Next, I've said that Levine's test indicated that the assumption of homogeneity or variance was met. And then again, I've inserted a couple of statistics. So we have an F value of 3.77 and a P value of 0.057. So if we go to the SPSS output and we scroll down a bit, we can find this homogeneity or variance test table. And here we can see the F value of 3.772. So I've just rounded that to 2 decimal places in the example results section. And here we have the sig value of 0.057. So often p-values are just reported as they appear in SPSS, so to 3 decimal places, whereas at least in APA style, the majority of other statistics are rounded to 2 decimal places. So next I've referred to the means and the standard deviations, and I've said that effectiveness ratings were significantly higher in the celebrity condition than in the no celebrity condition. So here are the means and standard deviations for the celebrity condition, and those are coming from this group statistics table. So here we can see in the celebrity row we have a mean of 79.77 if we round that to 2 decimal places, and we have a standard deviation of 7.98. So those are the 2 values that we have here, and then we just have the same thing for the no celebrity condition, and those are just these 2 values here. So next we have the results of the t-test itself. So we have t equals 4.33, and that t value is here, 4.332. So I've just rounded that to 2 decimal places. Here's the degrees of freedom of 58, and here's the p value of less than 0.001. So there's the degrees of freedom in brackets, and there's the p-value. And lastly, I've just said that the effect size was large, and then I've inserted this Cohen's d value, and I've said that Cohen's d was 1.12. So let's just take a look at where that comes from. So I'm getting that from this independent samples effect sizes table, and from this Cohen's d row, and from this point estimate column, where we have a value of 1.12 if we round this to 2 decimal places. So that's basically how you report the results of the test, but let's just take a look at why I've described this effect size as large. And so it's based on these criteria described here. So Cohen's d-values between 0 and 0.2 are typically considered to represent very small effects. Those between 0.2 and 0.5 represent small effects. Those between 0.5 and 0.8 represent medium effects. And those above 0.8 represent large effects. And as I've said here, those same cutoff points apply if you have a minus symbol before your Cohen's d statistic. So here we have a value of 1.12, and as this is bigger than 0.8, I've described that as a large effect. So that's about it for the independent t-test on version 31 of SPSS. I hope that was helpful. If you have any questions, just let me know in the comments. I'll try to get back to you. Thank you for watching, and I'll see you next time.